Inverse trigonometry second video, sine inverse of sine 3 pi by 5, which is example 9, okay, which is sine inverse of sine pi minus 2 pi by 5, and a pi minus is in the second quadrant, okay, and where sine is positive, solve the trigonometric part will be sine 2 pi by 5, okay, with the sine inverse on that side, which will be 2 pi by 5. That's example 9. Then is example 12, which is tan inverse of a cos x plus b, minus b sin x by a b cos x plus a sin x. As soon as I see the cos x minus sin x by cos x plus sin x, I know I have to throughout divide by cos x, but I'll divide throughout by b cos x to ensure I get a 1. So when I divide throughout by b cos x, I'll get a by b minus tan x by 1 plus a by b tan x, which resembles tan inverse of x minus y by 1 plus xy, where in the place of x you have a by b, in the place of y you have tan x, which is nothing but tan inverse of x minus tan inverse of y. So substituting tan inverse of x is a by b and minus tan inverse of y itself is tan x, and tan inverse and tan get cancelled, thus the answer is tan inverse of a by b minus x. So next is miscellaneous exercise. A cos inverse of cos 13 pi by 6, which is the first sum, which is cos inverse of cos, it is 2 pi minus pi by 6, 2 pi plus pi by 6, 12 pi plus pi 13 pi, yeah. To get a 13 pi by 6, you should write 2 pi plus. 2 pi plus will come in the first quadrant, where the trigonometric part when you solve, you get a cos pi by 6 with a cos inverse. Thus the answer itself is pi by 6. Let's go to second question, which is tan inverse of tan 7 pi by 6, which is tan inverse of tan pi plus pi by 6. What is pi plus pi by 6? This is 0, this is pi plus pi by 6 in the third quadrant, where the trigonometric part is just tan pi by 6, and a tan inverse gets, there is so far there has not been any negative argument in this exercise whatever we have done. Okay, so then that's it, and let's go to the ninth question. The ninth question, which is tan inverse of root x is half cos inverse of 1 minus x by 1 plus x, where if you put 1 minus x, 1 plus x as cos theta, 1 minus cos theta and 1 plus cos theta, you will get a tan square theta by 2. And there's nothing called a cos inverse of tan square theta by 2, does not even exist. So you cannot think of that, you should think of some other solution. So if it's cos inverse, it has to get a cos 2 theta. Therefore x is equal to tan square theta, tan theta is equal to root x. Theta therefore is tan inverse of root x. Kattam pottu vechukonga. Substitute right hand side cos inverse of, so 1 minus tan square theta by 1 plus tan square theta, which is half of cos inverse of cos 2 theta, half of 2 theta, 2 and 2 get cancelled, the answer is theta, theta itself is tan inverse of root x. That completes the 9th sum. Let's go to 10th. A cot inverse of root of 1 plus sin x plus root of 1 minus sin x by a root of 1 plus sin x minus root of 1 minus sin x. When you have a root of 1 plus sin x, it is cos x by 2 plus sin x by 2 the whole square, where the root and square get cancelled, plus this is cos x by 2 minus sin x by 2 the whole square, with the root and square get cancelled, by a root of cos x by 2 plus sin x by 2 the whole square, root and square again get cancelled, minus cos x by 2 minus sin x by 2 the whole square, with the root and square get cancelled. So you will get a cot inverse of 2 cos x by 2 by 2 sin x by 2. 2 and 2 get cancelled, cot inverse of cot x by 2, so thus the answer itself will be x by 2. So next question is the 11th sum. It's tan inverse of root of 1 plus x minus root of 1 minus x by root of 1 plus x plus root of 1 minus x. You have to prove it to be equal to pi by 4 minus half cos inverse of x. The moment you hear 1 plus cos x, 1 minus cos x, x is cos theta. So tan inverse of root of 1 plus cos theta minus root of 1 minus cos theta by root of 1 plus cos theta plus root of 1 minus cos theta, which itself is tan inverse of 1 plus cos x, 2 cos square x by 2. So root 2 cos x by 2 minus root 2 sin x by 2, because the root and square get cancelled, no? By a root 2 cos x by 2 plus root 2 sin x by 2. The root 2 throughout, when taken out common, get cancelled. You get a tan inverse of cos x by 2 minus sin x by 2 by a cos x by 2 a plus sin x by 2 throughout divided by cos x by 2, 1 minus tan x by 2 by 1 plus tan x by 2, and this itself is like tan pi by 4 minus tan x by 2 by 1 plus tan pi by 4 tan x by 2. So thus you get a tan inverse of tan pi by 4 minus x by 2. So pi by 4 minus x by 2, there's no substitution. Yeah, we have substituted. Theta is equal to cos inverse of x. So actually speaking, it should be theta by 2 everywhere. Should be theta by 2 because you've substituted x as cos theta, right? Should be. So then therefore this will be tan pi by 4 minus tan theta by 2 by 1 plus tan pi by 4 tan theta by 2. So it's tan pi by 4 minus theta by 2. So pi by 4 minus theta itself is cos inverse of x. Cos inverse of x by 2. So I hope you understood that. So if substitute x as theta, so you have to write completely in terms of theta. The 12th question. The 12th question is 9 pi by 8 minus 9 by 4 into sine inverse of 1 by 3. In this you can take 9 by 4 common, you will get a pi by 2 minus sine inverse of 1 by 3. A pi by 2 minus sine inverse 1 by 3 itself is cos inverse of 1 by 3 using identities. But to prove that answer, you have to prove it as sine inverse. How to convert a cos inverse into a sine inverse? Draw a triangle. Adjacent is 1, hypotenuse is 3. Therefore, this will be 2 root 2. So a cos inverse can be converted into sine inverse, which is opposite by hypotenuse, sine inverse of 2 root 2 by 3. So thus you get this answer by just doing a triangle. So 13th question. 13th question is 2 tan inverse of cos x is equal to tan inverse of 2 cosecant x. Okay, this is a solve sum. So till here we were doing prove that. But after this is solve, you have to use the right hand side. This is like 2 tan inverse of x. Where x, instead of x, this cos theta, which is tan inverse of 2x by 1 plus x square, 1 minus x square, I'm sorry. But you have to write this as x is cos theta, so tan inverse of 2 cos theta by 1 minus cos square theta, 1 minus cos square x is equal to tan inverse of 2 by sin x, the cosecant x. So tan inverse and tan inverse get cancelled. A 2 cos x by sin square x is equal to 2 by sin x. Sin x and sin x get cancelled. Thus you get a cot x is equal to 1, which will happen at x is equal to pi by 4. That's the 13th question. The 14th question is tan inverse of 1 minus x by 1 plus x is equal to half tan inverse of x. This is a different approach. Can you see it's x minus y by 1 plus xy, which is like tan inverse of x minus tan inverse of y, which is tan inverse of 1 minus tan inverse of x, which is half tan inverse of x. Taking this to the other side, a tan inverse of 1 is equal to 3 by 2 into tan inverse of x. And you know tan inverse of 1 is pi by 4, 3 by 2 tan inverse of x, this and this get cancelled. A tan inverse of x itself is pi by 6, the x is equal to tan pi by 6, a tan 30 itself is 1 by, tan 30 is 1 by root 3, this x is 1 by root 3. So let's go to 15th question. 15th question is sine of tan inverse of x. Simplify this, you want to get it as sine of sine inverse. To convert a tan inverse into sine inverse, just draw a triangle, opposite you write x, adjacent you write 1. The hypotenuse will be root of 1 plus x square. So thus the sine of sine inverse of opposite by hypotenuse, sine of sine inverse is x by root of 1 plus x square. The 16th question is on, which will come only for PS senior, no other school it will come. So 2 sin inverse x is equal to pi by 2. Take this to the other side. So other schools can probably ignore 2 sin inverse of x is equal to pi by 2 minus sin inverse of 1 minus x. This itself is cos inverse. Minus 2 sin inverse of x is equal to cos inverse of 1 minus x. Now you don't want 2 sin inverse of x. So just consider sin inverse of x as theta by 2. This sin theta by 2 becomes your x. So substituting minus 2 into theta by 2, 2 and 2 get cancelled, is equal to cos inverse of 1 minus sin theta by 2. Take the cos inverse to the other side, it will become cos theta. Cos of minus theta, which is just cos theta, is equal to 1 minus sin theta by 2. And you know cos theta itself is 1 minus 2 sin square theta by 2. It's 1 minus sin theta by 2. 1 and 1 get cancelled, minus minus get cancelled. You can group it all to one side. So sin theta by 2 can be taken out common. 2 sin theta by 2 minus 1 is equal to 0. Hence, as sin theta by 2 is equal to 0, or sin theta by 2 is equal to 1 by 2. This sin theta by 2 is nothing but x, and this is solved for x. We already got x. X is equal to 0, therefore x is equal to 1 by 2. But now this involves verification. You should substitute this in the question. X is equal to 0 will be the only valid answer. X is equal to 1 by 2 will not be a valid answer. You have to verify that, okay? Then 17th question is tan inverse of x by y minus tan inverse of x minus y by x plus y. Okay, this is like tan inverse of x minus tan inverse of y, which is tan inverse of x minus y by 1 plus xy. Consider this whole thing as x, this whole thing as y, and substitute. So tan inverse of x by y minus x minus y by x plus y by 1 plus x by y into x minus y by x plus y. You solve it, you will get tan inverse of x square plus y square by x square plus y square. Just try to solve it, you will get tan inverse of 1, and a tan inverse of 1 itself will be pi by 4. You have to take LCM and solve it, okay? So that completes this 7 exercise of miscellaneous. All these sums, I have omitted a few sums here and there which are not important, which have been omitted for the last 2 years. So I'm leaving those sums off. And PS Senior, I will do this missed out sums separately for you when we meet again, okay?